Students, now next unit is our dimensions. So this is a very important part of the syllabus as it cover most important parameter of the syllabus. So dimensions basically um, dimensions basically related to the units also. So since we have seen there are three units, one is called as mass, another is called as length, and another is third is called as the time. So these are the fundamental units. So we can represent all the quantities in the form of these three things. So that's why so for example area is written as length into breadth. So that means it has dimensions of L ki power 2. So means it has the dimensions of length 2 dimensions of length in the form of 2, but it do not have any dimensions in mass and it do not have any dimensions in time. So that means, so these are the dimensions which are being written. So either they are written in the form of m or L or in the form of T. So that means m represents the dimensions in the form of mass, L represents dimensions in the form of length, and T represent dimensions in the form of time. Now let us see, for example, we have got density. Density is defined as mass upon volume. So mass upon volume is defined as this one. So that is mass upon length cube. So that means it has dimension of mass 1 and L power minus 3. So the dimensions of mass 1, L minus 3, while dimensions of time is 0. So these are the different dimensions which are being written. But if anything which is written in the form of M0 L1 T0 or M0 L2 T0, so this thing is called as a dimensional formula. So if the things are written individually in the form of power of subscript of M, L and T, so these are called as dimension. But if they are combined together in one particular subscript, so that is called as the dimensional formula. For example, M0 L2 T0 is the dimensional formula of area of area. So similarly, a lot of things are there whose dimensions and dimensional formula can be written one by one. We will discuss one by one. Now let us see about volume. Volume of anything. Let us say it is a cuboid. Length into breadth into height. So all these are the dimensions of L, L1, L1 and L1. No mass, no time. So it will be L3, or it can be written as M0 L3 T0. So this is the dimension formula of volume. Then we have got another part that is called as speed. Speed is equal to distance upon time. Distance upon time. So distance is measured in the form of meter, so it is form of L, and time is measured in the form of second, it is in the form of time. So it has dimensions of L1 T minus 1, while mass do not have any one, so I can write it as M0 L1 T minus 1. So this is a dimension formula of speed. So this is how we can able to write the formula. Now let us discuss about the momentum. Momentum is equal to mass into velocity. Velocity or speed. So velocity we have discussed, it has L T minus 1 and mass has got 1. So it will be M1 L1 T minus 1. So this is the formula for momentum. How we are able to write it out. Then we have got acceleration. Acceleration can be defined as equal to velocity upon time. Velocity upon time. So that means velocity has got Lt minus 1 upon t. So it is Lt minus 2 or M0 L1 t minus 2. So this is a dimension formula for acceleration. Now next we have got force. Force is equal to mass into acceleration. So acceleration we have going to take previously one, but we have taken acceleration as m0 L1 t minus 2, and mass 1 it will be m1 L1 t minus 2. So these are the dimensions of the force. Now next is in the form of energy, which can be form of kinetic energy or potential energy. The formula of kinetic energy is mv square, half mv square, and formula for potential energy is mgh. Half do not have any dimension, so it has dimensions of m1, it has dimensions of lt minus 1 whole square, so it will be m1 L2 t minus 2. So this is the dimension formula for kinetic energy. Similarly, m1 has dimensions of m1, g is acceleration, it will be lt minus 2, height is l1, so it will be this one. So m1 L2 t minus 2. So whether it is energy, whether it is potential or kinetic, both will have the same units. So that means so the energy has the dimensions, whether it is kinetic or potential, so it has the dimensions of m1 l2 t minus 2. So similarly then we have defined work. Work is related to force into distance, force into distance. We have defined force as m1 l1 t minus 2 into l1. So it will be m1 l2 t minus 2. So you will see the work has a dimension same as that of energy. So because work is converted in the form of energy, so that is how the dimensions of the work is same as that of energy. Then another important thing is about power. Power is defined as work upon time. So power is defined as work upon time. So it was work has on m1 l2 t minus 2 divided by t. So it will be m1 l2 t minus 3. So these are the basic units which we have discussed for all the small simple quantity. Similarly, next we will discuss some more complicated quantities, and we will discuss in details.